Welcome back to stream. What's going on? Alright, we're back. We're back doing this thing again, huh? What do you know? We're back. I go in the other room and the kitty just runs away. What is this disrespect? Kitty. Yo! How's it going, everybody? Welcome back to the stream. I hope you're having a wonderful day so far. Welcome back, welcome back. Should be a good one today. Let's go with. Timing's a little off here. How's it going, everybody? Welcome back to the stream. I hope everyone's having a good day. Welcome back. Let's go ahead and get this thing rolling, yeah? Feeling good today. Gonna start out with a Leet code problem, probably. And then I think I'm gonna start a new project. I want to make a visualizer in Python of all of my just like of stock assets, basically all in one place, like a centralized dashboard. So I think we could do that pretty easily with some object-oriented classes, and then just write a quick script to load up some information. Then we can store it in a SQLite database, and yeah, it could be a pretty cool little quick project for us to build over the course of a few days. So I say that now, but then maybe it'll take us forever to build after that. But yeah, I think that's kind of fun to do. Anyway, yeah, let's go ahead and get into Leet code today. How about yeah? The Leet code. Do not disturb is on. Let's make sure everything else is closed. Close that. All those spam calls will begin. I think we're good. Okay, let's get rolling here. Let's go to our problems. Let me know what you guys are working on, what you're studying tonight. Appreciate you guys joining me here. All right, we got 84 solved, so hopefully today we'll have 85, maybe 86. We'll see how far we get. All right, you guys, let's go ahead and roll the dice here. Come on. If it's hard, I don't think I'm going to do it, but we'll see. We got a medium. Ooh. All right, we didn't get too unlucky, but we didn't get lucky today. No, luck is not on our side today, boys. All right, you are given a string S. This is a 3081. Replace question marks in string to minimize its value. You're given a string S. String S, index of some I value or index, is either a lowercase English letter or a question mark. For a string T to have length M containing only lowercase English letters, we define the function cost on I. For an index of I as the integer, as the number of characters equals to, whoa, hold up. For a string T having some M length containing only lowercase English letters, right? We define the function cost of I, right? For an index I as the number of characters equal to T index of I. So it's the string of I that appears before it. We define the function for an index of I as the number of characters equal to T index I that appear before it, either in the range of 0 to I minus 1. The value of T is the sum of cost index I for all indices of I. For example, for the string AAB, forced to play up by 30 minutes right now. up by 30 right now. Game 7, huh? The NBA is rigged like that, huh? They forced a Game 7 to drag it on. All right. Nah, dude, who honestly cares? Pacers OKC. Now throw the Blazers in there. Let's go. All right, so for the string AAB, cost at index 0 is 0. Cost at index 1 is 1. Cost at index 2 is 0. Hence the value is 0 plus 1 plus 0 equals to 1. Your task is to replace all occurrences of the question mark in the string S with any lowercase English letter so that the value of S is minimized. Oh my gosh. Okay. I'm only going to work on this one for maybe like 30 minutes. I'm not going to grind super hard on this, because I want to do other stuff today. But I can already tell this might be a little bit difficult. Okay, so let's just think about it first. We don't need to jump into code right away. Let's just think. Okay, return a string denoting the modified string with the replaced occurrences of the question mark. If there are multiple strings resulting in minimum values, return the lexicographically smaller one. A is lexicographically smaller than a string B if the first position where A and B differ. String A has a letter that appears early in the alphabet than the corresponding letter in B. If the first characters do not differ, then the shorter string is the lexicographically smaller one. Okay. Okay, this one looks a little bit more difficult, you guys. Okay, let's think about this one. So we need to have a function cost here that we define as well, right? Oh my gosh. I don't know. Should we start off with the easier one for a warm-up, Tim? What do you think? I don't know if I want to go about this one right now. There's the draw, though. Okay, so we have a string S with some... Okay. So the thing is if you come across... You need to minimize the values. So characters that you haven't seen before, basically. Okay, so we're going to have a hash map of occurrences, right? So let's say our frequency map is equal to here, okay? We're going to save values in the frequency map, but I'm going to define a function called def cost here of some I, which is an integer. And this is going to return an integer back. Right? So this function is going to be given this integer. So we're going to access frequency.get the integer, the count of this, if it's there, else 0. Okay. And so then we're going to just return this. Okay, so this function is going to return the frequency of the letter that we've seen so far. Okay. So we need to add letters in the alphabet. So we have to, the thing that's tripping me up though, the thing that's tripping me up though is this whole thing about um the minimization, right? ABC so 000. The next character letter that you haven't seen before, right? Okay, so maybe we should sort this string. No, but the order of the string matters because it goes before it. So the cost function will get the value of the frequency, right? And okay. So it gets added to the frequency. Let's return 0. If there is no frequency, it's not in there, right? We'll get this less than 1. Okay, so the question then is, so if I need to get the smallest one though, so like, so if I say like for value, or for char, or let's say, yeah, for char in S, or in for I in range length of S, right? If S index, we're gonna come across a character, we're gonna add it to the frequency. So let's add, update the char frequency. Add slash update the char frequency. So we're going to go into our frequency, access the index of I, but this will be S index of I. We're going to update this to be frequency.get I feel like I have to like sort somewhere, but I'm not sure exactly. So for I in the range length of S, we're going to update the frequency map with the current cost value. Yeah, I think it's the current cost, right, of frequency to get S. So frequency dot get s index of I. Well, maybe I don't have to write this function. Cost. Okay, let's just do this then. Okay, let's update the frequency here as frequency.get s index of I L0, right? And then we're going to update by adding the current value that we are on. Okay, so we update the current value of the character in the string s. But we need to first say if s index of I equal to a question mark, what are we going to do here? We need to replace this with a value that has not yet occurred, but that is next in line. So we need to prioritize the okay, let's just say while true, or while so I'll say char is equal to ord as the next I. So we're going to take the character okay, let's go like this. Let's take the character. So what does the ord do? I forgot again. Is it that the number or is it sure? Code point, okay. Yeah, so point is equal to this. Or I'll say value, right? Or say if no, hold on. So this is gonna go sure. So should I keep like a sorted array then of all current characters then? Like sort the frequency map, like a sorted map? Or something like that? Because my idea is that I take the or the value, I check if it's in the map. If it is, I continually increase the value by 1 until it's no longer in the map, and then but it's all lowercase English letters. Alright, so let's think about this. Let's pull out the whiteboard. Okay, so I have my map, right? Okay, this is gonna house counts. I'm gonna loop over every value, like a question mark, right? Okay, a goes into the map on index of 0. I would go here. Okay, I'm gonna say let's have like a set of scene values, right? If it's in scene. Continually increase the value by 1 until you get the next character. And I want to start at like the beginning at like 20. So let me pull up a like ask key. So lowercase letters are 97 through 122. Okay, let me do this really quick. Let me say print ord s index 0. I want to see what that gives. What I want to make sure the ord function I know what it's doing. 63 of the question mark. And in my ask key chart, question mark is 63. Perfect. Okay, good. So then let's go ahead and say let's go ahead and say let's go ahead and think. Okay, so what do I want to accomplish though? Like I want to loop through the array. Okay. I want to loop through the array. Let me write this down. I think it'd be easier to write this stuff down. Okay, what do I want to accomplish exactly? Okay, I want to I want to loop through a string s. Okay. If s index of I is equal to a literal question mark. What do we want to do if it's equal to a question mark? We want to check if it's a question, add next available char, not in frequency. Oh, okay, I think I get it. Okay, let's do this. Let's go like this. Let's say frequency is equal to a dictionary. Let's say chur value for value in range of chur value with a count of 0. for value in range of what was it in our frequency ASCII chart, right? 61 or 97 through 123 exclusive. Okay, so this is going to build a map of all letters of the alphabet. Okay. Lowercase, right? So now let me go ahead and print frequency here. Beautiful. Oh, I think, okay. Come on, Mike. You're cooking now, boy. Okay, so I think we got a frequency map already created here. I'm going to say, I say n equals to the length of s for value for char in for I in range of n, right? We're going to frequency, update the frequency, or say check if s index of I is question mark. So if s index I is equal to a question mark, we are going to, while true, while frequency index of so I'm going to say that value equals to frequency, I'll say start is equal to, and I'll say value is equal to frequency index of, we'll just grab A first, right, which is 22, or no, 97. Which would be true 9, or let's say, okay, while let's see, so okay, we'll say while true, if frequency index of A, or frequency dot get, right, equal to 0. If frequency dot get if you run this function frequency dot get index of A, then we're going to what do we want to do here? If s index of I is equal to question mark, we're going to enter a loop and continually okay. Okay, then I'm going to create, what if I created a list? I don't know, this is kind of risky, like available is equal to a list of So how can I detect the next one? Okay, let's go here. Let's have a list of used, right? They're going to keep. We're going to go like this, while true. No, we're going to go new largest. Largest is equal to none. So if s index is 0, I is equal to the question mark, so else I'm going to say largest that can be is equal to 0 if ord s index of I greater than largest. Let's go ahead and set largest equal to s equal to okay. So if we set it to the value, the ASCII value of that character, right? If we set it to the ASCII value of that character, so if it's question mark, we want to go to the largest, add it by 1, check the frequency if it's in there. No, but the largest really doesn't do much for us actually, because we don't really care about the largest value, because that one right. So I need to loop through the frequency map until I find a valid next character, right? Basically. Okay, so let's go like this. Well, let's say this zeros equals to what if we go here and do that zeros is a list called every value that we have 0 for, right? So sure value for value in this range. No. So this is in. It's in, get the value. It's 0. Well, they're all going to be in, so you just need to get the value. So what's the what is like? How can we get the value of the next available character? So if we see one, let's add it, rather than adding them all up front. If it's in there. So let's go just a frequency map then. So let's say if the character is a question mark, we're going to, can we get the next available character? If the character is a question mark, we need to access a value that would be the next character that has none. So I'll say find next given so find next. I'm going to call a function here called def find next, which is going to be while true, value equals to frequency dot get a we gotta find a value that's not in there. Just start from the beginning. So while true, value equals to frequency dot get index value of a. We want to then, if it's not, so if it's not there, we'll go, if it's not there, we'll say 0, so there's none. So if value, so I'm going to say start is equal to quote a, right? Say while start not in frequency, we're going to get the value of start. If the value of start is equal to 0, right? This is my 83rd, I think, 84th, something like that. Okay. So if the value is equal to 0, then what do we want to do? Meaning that there is no occurrence. So we're going to return the start. Okay, else start is equal to chur ord start plus 1. So if it's in the frequency map, return start. So if it's, hold on, so find next given just the starting value. A string A is lexicographically smaller than string B if the first position where A and B differ. String A has a letter that appears early in the alphabet and corresponding with B. If the first characters do not differ, then the shorter string is lexicographically the smaller one. So it's just on the first characters, actually. Oh. It's not for every character. Okay, so then we just need to find the let me look up lexicographically. In these dictionaries, the way the words are sorted. At the first position where they differ. Oh, okay, so it is on differing positions. So you have to give the smallest string, so the earliest character that isn't seen so far, basically. So if you come across, like, if you have B, question mark, you have to put an A right there. You can't put like a C, right? Even though C would work, A should go there because it goes first. So you need to start on A. Given some starting point, let's put here, which is some stir, right? Okay, so find next, given some starting point. If start is not in the frequency, so do we want it to be, do we want start to be in the frequency, the A? So if it is in the frequency, that means it's currently being counted. Okay, so like, I'll start not, hold on, so I'll start not in the frequency. So start not being in the frequency, what would that do? So if it's not in there, if A isn't in there, do we want to do this move? So let's just say, well, true, I guess. Let's get the value of our starting point, starting string. If it's 0, you're going to return that. Else update the start to the next character. If start is equal to a bracket, right, then we're going to put start equal to a. So hold on, I don't know what I'm doing. Okay, so I don't know why these make me struggle so bad. Okay, so I don't even know if I'm doing the right thing here. So given a starting string, move through the string S. Okay, find next while true. Value equals frequency dot get start. While start not equal to a bracket. going to set update start to this new value. If it hits this, it'll break. And this will return A. Return the next available. There is no 0. And we'll say desired value. Right? So if you've already found a loop for all frequencies, the thing is though, is if you've already found a loop for all frequencies, okay, we've been doing this 50 minutes. It's time to get a little bit of assistance here. We're not going to get code here. We're going to walk through it together. So let's go. Hello. I am working on Leet code 3081 and am getting stuck. I would like to talk through. I'm working on Leet code number 3081 and am getting a little stuck throughout the process, and I would like to talk and reason through my thinking and potentially get pointed down the right path. I do not want you to show me any code or solve the problem for me. I want to do it all myself and learn it independently with just some guidance. Let me paste in my current attempt, which is pretty vague. My current thinking is that I need to loop through the string S, and if I find a character in string S that is equal to a question mark, I need to go into a map that counts the frequencies of these characters and somehow track the next available character, starting maybe from the ASCII value of lowercase quote unquote a, and checking from there forward with a function you'll see as find next. Okay, let's see. Awesome, you're approaching this exactly the right way by reasoning aloud and thinking iteratively. Let's unpack what you said and help guide you through the logic without giving code. Problem solving in terms. You're giving a string S with letters and question mark characters. Your goal is to replace each question mark with a lowercase character A through Z such that your resulting string is lexicographically minimal, under the condition that you're balancing character frequency. So yes, you're on track. You want to reassign replacements, assign replacements in a way that minimizes frequency imbalance while also trying to keep the string lexicographically small. Your find next function is a great idea, a helper function to walk through characters starting from A and find the best candidate based on frequency. Your thought: start on A, check frequency, and choose the first character with the lowest possible frequency. Smart. A couple of questions to guide you. Should find next always return the first character with a specified desired frequency, or should return the smallest character among all characters with the minimum frequency? How will you keep frequency updated? How will you keep frequency updated after assigning a letter? High-level strategy to consider. You might want to count the frequency of all non-question mark characters first. Then for each question mark, assign it a letter that currently has the lowest frequency, and it is lexicographically small among those with that frequency. things to think about. How will you determine? Okay, so you might want to count the frequency of all non-string characters first, then for each question mark assign a date letter. Currently. This creates a greedy frequency balancing problem. Things to think about though. How will you determine what the current minimum frequency is in your frequency map? Should find next use the value. Yes, let's try that. This is our input. First, go through the string and count the frequency of a non-question mark character. A is equal to 1, B is equal to 1, and question mark is equal to 2, but we don't track question marks in the map. So we would get an initial frequency of all of our characters. Go replace each string, each question mark with a lowercase character such that the overall string is lexicographically smallest and the frequency of characters are balanced as possible. So you get all the frequencies of those characters. Okay, so if it's not in there, so let's do this. Okay. I do not know any Java. Sorry, dude. Just Python, really, for me. Okay, so we're going to say our frequency map is equal to this. We're going to first loop through and count the values. Okay, so we're going to say for char in S, if char not equal to a question mark, we're going to go frequency index of char dot get equals to frequency dot get char, well, it's 0. And we're going to assign it. Okay. We then want to so we need to, let's count question marks is equal to 0. Let's say else, if it is, we're going to question marks plus equal 1. Okay. We're going to say while, this is going to be question marks, and we're going to say indexes. Is equal to a list. Okay. So then we're going to say if you get one, you're going to go so I'll do this actually. N is equal to the length of S. We'll use I here, range of S. Let's do char is equal to S index of I. Here let's say I is our index, so index dot append I. Okay, so that'll map. Now we're keeping track of the indexes. So then we can go like this and say, for while question marks is greater than 0, right, while question marks is greater than 0, I want to, hey Justin, how's it going? Welcome, dude. While question marks is greater than 0, let's go ahead and say, let's say, so I'll say minimum is equal to 0 here. Let's find the smallest. Can I keep like a list of like if I sorted that, it'd be a lot, it'd be easy, but sorting is difficult. Okay, so while question marks is greater than 0, we're going to find the minimum within the frequency, right? While question marks is greater than 0, we need to replace question marks, the question mark count, right? So we need to loop to say for in range question mark, right? This is going to loop the amount of times that we have question marks. We're going to get the 3 smallest frequencies out of our frequency map. I don't want to go over all the data because I've taken that one. It increases frequency. Okay, so we'd have to say for key value for char and frequency, in freak items, we can only have a value that's a maximum count. So you can find the smallest one though right off the bat here because you're doing it into frequency, you're getting it. So I'll say smallest, you're doing an initial loop here. So let's go smallest is going to be equal to 1. where you have at least one character. No, so I'll say the smallest is at least the length of, which is at least n, right? So at the very, and so we're going to reduce it from there. So if we're going to get this character count, so I'm going to take this, move this down. So let me get the value. I'm going to say if value, if the value is greater, less than smallest, then value the smallest becomes value. And we set frequency no matter what there. Right? If the value is less than smallest, then we're going to override smallest here. Okay, so then we're going to just go and go from smallest okay, I'm gonna try some more, another like attempt here at some, maybe a point in the right direction here. You're thinking along the right lines, you're structuring about shipping 19 let's walk through. What you're doing so far and doing right, building a frequency map of non question mark characters, counting how many times question mark appears in storing their indices, also smart, tracking the current minimum frequency so far, helpful for optimization. You're getting ready to loop through the number of question marks to decide replacements. You're basically planning for each question mark, find the lexicographically smallest character within the current minimum frequency, and assign it and update it. So I could technically get an order though. The smallest will end up at the end. And you can pop off values. Smaller and smaller. But that doesn't... Your loop for I in range S, you're looping over a string directly. Oh. You're tracking smallest frequency by building frequency. If I remember, frequency might change the answer. Key is to now look across all 26 characters, find the lowest current count. So then let me... Okay, let's do this. Let's go here and go chur val or val 157 to 122, 123. Okay, let's go for, so say n is equal to the length of S, question mark count is equal to 0 for I in range n if S index of I not equal to a question mark, then we're going to update the frequency of S index of I is equal to frequent. Get S index of I else 0. It will be in there. Plus 1. Okay. So then I'll also keep question mark indexes lists. Okay. Else if it is equal to a question mark count goes up by 1, question mark index dot append append Pacers 1. Nice, dude. So we want to append the index. So maybe I should start from the back so I can get the then I'll loop through the indexes. Pop off the. We start from the back and append those. So then let me actually, I is going to be range of n to n minus 1 to 0, right? So I'm going to loop through this backwards, okay? Now, this will be exclusive, so this will be negative 1. Hold on, so maybe we need to go actually range of 0 to n flip minus 1, right? Just go backwards. Okay. So then we're going to append here I to the index count. So it's going to go backwards. We find an index at, let's say, like 5. That 5 goes into there. Then we find one at 4. Then 4 gets appended. So then when we pop indices off, we're doing that in constant time. And so then we can use that to fill the array instantly. Okay. So let's go backwards. We'll increase the append. So if it equals to a question mark. Okay. So if it is not equal to a question mark, we increase the frequency of the letter. Okay. So B got increased. No. Top 5 NBA finals since 2000? Um, hmm. Well, obviously Warriors Cavs. Crazy series. Miami against who did they play? Was it the Spurs? Um, dude, honestly, I don't watch them if Portland's not in, which they haven't been. Okay, so we start from the back. Okay, and then I say. Okay, so I'm gonna take what I have so far. I'm getting a little bit lost. Man, these problems are hard, dude. Great progress. You're trying the logic. We're almost there. Let's pause. When you're creating a frequency map with all lowercase letters using the ASCII codes, you're iterating over the string to count non-question mark frequencies. Track the count of positions of the question marks. This is the correct spirit. You're now fixing all technical issues in your current draft. The line's almost perfect. True value should be true value. My bad. Let's do plus equal 1, right? I wanted to go backwards through the string so I could get indexes in reverse order so I could pop from the list and use them in constant time to dynamically set the new string. Now let's reverse into clever optimization. You want to traverse the string backwards so that the list of the question mark indices in reverse order, allowing you to pop from the end in constant time during replacement. Negative n to negative 1. Then this works correctly. N minus 1. Okay, so you go to n minus 1 to negative 1 with a reverse step. So what is this? Okay, so you start at n minus 1 at the back. You go okay. Interesting. Hey Prism, how's it going, dude? Welcome back in. Okay, so next. Okay. So we're gonna say for okay, small. Okay, so for key. No, so say for blank in range of QM count. We're going to We're going to do this as many times as we have question marks. What are we going to do? Well, we're going to say, okay, for key value in frequency, say smallest is going to be equal to at most n, right? So if value less than smallest will become the value, okay, else we're going to just continue on. I don't know, I like the random nugs. It's kind of fun to get hit with a blind problem. It keeps you on your toes. Helps me think in, like, I don't know. It's kind of fun. Challenge ourselves. Okay, so we're going to loop over our question mark count and find the smallest value within the keys of each time, right? We're going to get the smallest, which is equal to n. And I'm going to say smallest letter is equal to none here. Okay. If you set the smallest, you're going to set the smallest letter equal to the key, right? And so at the end of this, we're going to go into string index of qm index dot pop will equal to the smallest letter. Okay. And then at the end of this, we're going to return s. Oh. Hmm. So then I need to update this string, find the 3 letters, and then update the string. And then update the string. I can't directly assign. Okay, I can't directly assign inside the string. The index. right? So I am trying to reassign the key during the loop over question mark count for the frequency, and Budsters don't support assignment. Can't do say the replacement of a char of a plane. Okay, let's see characters. Okay, so then what we'll do is we're already looping over the characters here. So I guess I don't need this. Don't need this. And I don't need this. And then we'll just go to n, right? And then, but I will keep a list of chars is equal to a list here. I'm going to do, no matter what, chars dot append s index of I. Okay. So that does that no matter what. So now what I'll do is I'm looping 3 times over here. It's equal to this. Okay, so then if I increase the question mark count, if the value is less than the smallest, I'm gonna do that. I can't do this, right? So on each pass to the question mark, I get the smallest letter, and then what I do is I will use the smallest letter to replace okay, so then what we'll do is let's go for so I'll say t is equal to an empty string for I in the range of n here. Smallest equals to n on the first count. If s index of I does not equal to a question mark, then what we're going to do is go t plus equals to s index of I, right? Else, we're going to go ahead and say it is equal to a question mark, so we're going to need to find the smallest, right? And then set s index of I plus equal to, or sorry, t plus equal to smallest letter, right? Thanks, Tim, dude. I appreciate you coming in. Slower night tonight, huh? Okay. Oh, so this is return. We need to return T here. A. B. Huh. We're just off. Okay, so let's see here. Okay, so we're looping over, gathering all the chars, adding to a string. If s index I is not equal to a question mark, we add just to add that character. If it is equal to a question mark, we ping for the smallest character. Huh. I'm confused here, so let's try. I think we're really close. Building a frequency map A to Z with initial zeros, looping through the string, counting all extra characters, tracking number of question marks, building a chars list, though you're not using it yet. We'll come back to that. I don't even need to do this. Frequency is not being updated after replacement. Oh yes, that's right. So if we find the smallest letter and we do this assignment, then we're going to do frequency of smallest letter, right, will be increased by 1. Oh, so close. Was he a? They both had. Okay. So actually, if so, then we're going to just break out of this loop. No. Once you found the smallest, oh no, you don't break. So if value is equal to 0, you just turn right away. Let me break here right away. You don't even need to do anything. Let's see where we're having some issues. You're smart. String, check signs it. So far, everything is your inner loop. Once where you find the smallest letter, This is efficient and works correctly, but there's slightly more elegant mental model. Instead of short-circuiting a value at 0, let the loop find the full true global minimum, then rely on lexicographical order to break ties, which already happens by default due to iterating from A to Z. This means by default you could safely remove if value equals to 0, break entirely, and the behavior should be correctly even better balanced. You're currently building the string T with plus equals just fine with small inputs. Okay, so then let's add chars here back again. Let's do chars dot append s index I, and let's go for I in range if chars index I is equal to this, chars index of I will become equal to so if it is equal to this, let's find the smallest letter. Reduce the frequency. Churn. Is it chars.join like that? Oh, join on chars. So the string we want to choose on .join. So we want to join together with no spaces on chars. All the characters together, like so. Pin chars. Oh, this is difficult, man. This problem's hard. So many different edge cases. I like walking through it though. Identify all those. Yes. What's missing? You didn't actually replace the question marks in the list. Fail this test case. ZA. So I think that could be correct, but we just have one slight issue. I'll give it. Doesn't work. Should be AZ. ABC. So I hmm. I gotta reach the Bible. You're eating 10 candies, guys. So my approach is wrong. You are correctly picking the lowest frequency letter. You are correctly picking, but you are ensuring the overall maximum frequency is minimized globally across all replacements. Because you always pick the letter with the current lowest frequency at each step, you may accidentally create a final distribution where one letter's frequency is higher than necessary. Example, imagine you have 30 question marks and 26 letters. If you greedily pick the lowest frequency letter each time without cycling through the sorted letters fairly, some letters maybe end up with 2, others with 1. What you need to do to figure out the minimal max, the smallest max frequency achieved. Assign the letters so that no frequency max. Oh my gosh, screw this problem. Alright guys, stream's kind of dead tonight. I think I'm gonna head out tonight. There's like no chatters, no nothing. Got stuck on a medium one today. Struggle is real tonight, boys. Anyways, I'll see you guys tomorrow. Thanks so much for being here. Weren't able to solve one, unfortunately, today. That really was a bummer. Let's see, one random one. Let's go random. Given a number array consisting of 2 n elements, return the array of the form x1, y1. Okay, so if you divide the length by 2, what does n do? By 4. 2 by 4 elements. Oh, 8. Okay. So if you reduce the array by in half, that takes you to so it's always an even number. elements. So if I say 4 divided by 2, 2, so I substitute the first two elements, up to divided by 2. Minus 3. Okay, so n is always half the array, right? Okay. So let's just do this. Result is equal to this array. We're going to say for I in range, so we'll say m is equal to m is equal to the length of nums. We're going to say the blind 75, probably only like 10 questions, I think. I didn't do too many. I kind of like the Leet code more. I don't know. I like the randomness of it. M equals length of numbers, right? Or say for I in the range of m. Okay. I'm going to say result dot append nums index I result dot append nums. This is going to go up to, sorry, actually up to n. Nums index I plus n. So it's going to be 0 and access the third. And we're going to return results. Typo doesn't count. Typos don't count. Don't count as fails. They don't count as fails. Let's go. So what if I go let's just do this. Return an array of nums index of val return. Can I do this in a single list comprehension? This is my result here. So when I say okay, so it has to be open. This is pretty standard. Okay, 1470. Cool. Let's say I gave up on that one for today. Here is my successful solution for 1470. Why this works. Your problem gives you a number, you're entered. You try to do it in place without using extra space. So we just need to swap values, right? So swap values. Okay, so I just need to go every pointers. Okay, and skip. Okay, let's do this. Let's go like this. Let's do pointers and say for I in range of n. Let's say that we want to go n with a skip of 0 to n with a skip of 2, every other value, right? We're going to say left is equal to n nums index of I, right equals to nums index that swaps those two values, and then we move, which is that. No. Bit manipulation. All right, you guys, I'm heading out for tonight. I'll see you guys tomorrow, where we're going to start our new project, my portfolio kind of collection. So I'll talk to you guys.